Good morning, students. So welcome back. Starting with testing techniques again. We have done boundary value analysis and equivalence class partitioning. Now another technique is state table based testing, which is a black box testing for designing the test case, right? And it's a dynamic type testing. So what do you mean by a state table based testing? Where we are going to use the table actually, right? State table we mean is where, like for an operating system, you see whenever any input is given or an event is given, in that case state changes from say new to ready or waiting state, right? So this table represents the transition actually, where the state is getting changed from one form to another. So there are certain prerequisites to understand state table based testing. First one is finite state machine. So you must know what is exactly a finite state machine. It is a behavioral model whose outcome depends upon both previous and current input, right? So FSM is what? Where the output depends upon current and previous inputs. Now this FSM model can be prepared for software structure or software behavior. That means it is used to model the behavior of the system. And it can be used as a tool for functional testing, like we'll be using here. It's a black box testing approach. That means we'll be checking the functionality of our system. Now second thing which is important is a state transition diagram or a state graph, right? So what is a state graph or state transition diagram? It's a system or its components may have a number of states depending upon its input and time. For example, a task in an operating system can have the following states. Understand what is a state, and then we'll talk about state graph. So in an operating system, we can have a new state when a new task is created, ready state when a task is waiting in the ready queue, running when the instructions of the task are being executed, waiting when the task is waiting for an input-output event or reception of a signal, and terminated when the task has finished execution. So that means we have 5 distinct states now. Right? Now, what is a state graph for this particular example? We are going to make this state graph represented with this figure, and there are 2 types of information which is being represented. First of all, the states is written in a node. The circle represents a node: new, ready, running, waiting, and terminated. While this arrow is used to show the transition from one state to another, and it mentions 2 important parameters here. This is what admitted is a transition event. So if you apply admit event on new state, it will change the state from new to ready, and the resulting output will be T1. Right? So what is admit? Admit is a transition event which is changing the state from new to ready, and the resulting output is T1. Now what is this T1, T2, T3? So T0 is the initial task or a new state. T1 is a new task admitted to ready queue. T2 is a ready task has started running. T3 running task has been interrupted. T4 running task is waiting. T5 waiting period of waiting task is over, and T6 task has completed execution. So understand with this diagram. So if you apply admit event on a new state, it changes state from new to ready, and output will be T1. In the ready state, if you apply dispatch, right, that means state changes from ready to running, and outcome will be T2. Now while you are at the running state, 3 options are there in fact. Either your task gets completed, so will exit, and the change will be terminated, right? That is T6 output. But if there is an interrupt, you haven't completed your task and someone interrupts it, you come back to ready state and the output is T3. While if you are running an execution, gets completed, input output wait over, so you come to the waiting state and output is T4. While you are into waiting state, if you apply input output even completion, so you will change it to ready state again. So that is T5 will be your output. So this is how the states are getting changed. So this is a state graph. So 2 things we have learned. First of all, what is a finite state machine, and second one, what is a state graph. So state graph represents your states and the events in the outputs. Now what is state table? When we have a you can say lot many states in any of the problem. So if you're representing it with the help of a state graph, it becomes a complex and a chaotic structure when number of nodes increases actually. So in that case, if the problem is very large, so in that case we take the help of tables actually. Table is the best way to represent our information. Right? Now state table, what does it specifies? It specifies the states, inputs, transitions and output. That is the same thing which is represented with the help of a state graph will be represented with the help of a table which is systematically arranged in the form of rows and columns. Now each row of the table corresponds to a state while each column corresponds to an input condition. And the box at the intersection of the row and column specifies the next state, that is a transition in the output if any. Understand with this, right? This was a graph. Now for this particular graph we have made this transition table. So new, ready, running and waiting. That means this left hand side represents the state, that is rows, while this columns represents your events, admit event, dispatch event, interrupt, input output or event wait, input output or event, you can say completion, you can like over, wait over and exit. So this is what rows represents states, column represents your events, and we have written the transitions at the intersection of each of these rows and columns. So ready, output will be T1. So understand with the diagram. Now look at it. If you are at a new state, right, and we apply admit event, so the state is changed from new to ready and the output is T1. This is how you will understand this table. Let's take second one. You are at a new state and we apply dispatch event. Now at the new we can only apply admit. Dispatch is not there. That means you will still remain in the new state and output is T0. So similarly for all the cases other than admit, you will remain in the new state with output as T0. Now coming up to the second one, that is a ready state. In the ready state, if you apply ready, which is not possible, so that is if you apply admit actually on the ready state, it will remain in the same ready state and output will remain the same T1. There will be no change. But if you are in the ready state and you apply dispatch, now look at the graph, ready and dispatch. So state is changed to running and output will be T2. This is how the table is developed using this state graph, right? Third, fourth, fifth, another entries will remain the same. While you are at the running state now, for the first two admit and dispatch, there will be no change. But while an interrupt is applied in the running state, you will change the state to ready and T3 will be output. If you apply input output wait, the state is changed from running to waiting and the output is T4. And you apply exit, the state is changed to terminated and T6. Similarly for waiting, for all others it will remain the same except for input output event wait, right? Here it is changed to ready and T5. So this is how the table is developed. Now these highlighted cells of the table are valid inputs causing a change of state, while others are the invalid inputs due to which no change is being represented. So this is what the bold ones are the valid inputs, rest are the invalid inputs. Now the last task is to design the state table, right? That means you have to design the test cases actually now. So what is the, first of all, look at the steps. First of all, identify the states, prepare a state transition diagram, convert the state transition diagram or a graph into corresponding table, analyze the table for its completeness. Now create the corresponding test cases. So we have done till 4. Now the fifth one is how to design a test case using this state table. No, so as per the table we have developed, compare it there, the cell 1 is this, the first one, ready, T1, this is cell 1, right? So for cell 1, current state is new, you apply event admit, so the output is T1 and the state is changed to ready. Similarly for cell 2, we were at new state, current state is new, we apply dispatch event. Since there is no change, the output will remain T0 and even the state will remain the same, that is a new state. So for all the cells, how many cells are there now? 4 rows, 6 columns. So 24 test cases will be designed for each cell in this table. So see, we'll have 24 test cases. For each cell you will identify the current state, the event that is applied, what is the expected result, that means the output, and the change state that you need to prepare here. So this is what state table based testing is. Okay, thank you for today.